Hello everyone, welcome back to this channel. So let's continue our intro to machine learning course. And in our first class, we understood how models work and then the basic data exploration. Here, if you remember, we used a Melbourne housing prices dataset and we saw how to use the describe function to find the statistical measures of the dataset. Okay, and after that, we did the exercise. Later, we built a model using disease entry. See, the same dataset, Melbourne house pricing dataset, and we used, and first we selected the prediction target, that is Y. So we had to find the prices of any houses. And we also choose the features, these are the inputs. So these are the inputs, price is the output, and then we build the model using disease entry algorithm. Okay, and also we used fit function to fit the algorithm. Then we did the exercise. Okay, so these things are done, and today we are going to understand model validation. First, we will read, then we will do the exercise. Okay. Now, first, let me read line by line. You have built a model, but how good is it? In this lesson, you will learn to use model validation to measure the quality of your model. Measuring model quality is the key to iteratively improving your model. What is model validation? You will want to evaluate almost every model you ever build. Exactly. Once you build a model, your model is giving some output, but you want to know whether it is giving the right output or the wrong output. So you have to evaluate the model. You have to validate the model. Okay. Now the relevant measure of model quality is predictive accuracy. How much accurate it is? 80%, 85%, 90%. Then you will be able to understand how your model is performing. So in other words, will the model's prediction be close to what actually happens? Simple. Now, many people make a huge mistake when measuring the predictive accuracy. They make predictions with the training data and compare those predictions to the target values in the training data. So, you will see the problem with this approach and how to solve it in a moment. Let's think about how we would do this first. Okay, see, you would first need to summarize the model quality into an understandable way. If you compare predicted and actual home values for 10,000 houses, you will likely find mix of good and bad predictions. Looking through a list of 10,000 predicted and actual values will be pointless. We need to summarize this into a single matrix. Suppose you have 10,000 houses. So your model has predicted prices of 10,000 houses. Okay, and in your actual data you have the prices of 10,000. Now what will you do? You will compare with all those predicted values with all those actual values. That is kind of pointless. So we can summarize this into a single metric. And what is the name of this metric? We will read this. There are many metrics, but we will start with mean absolute error. There are mean, standard error, and many other metrics which we will study later on when we will study the algorithms. But for now, just understand mean absolute error is a metric which will give you the comparison of predicted values and actual values. Okay. Now the prediction error for each house is error equal to actual value minus predicted value. So if a house cost $1,50,000 and you predicted it would cost $1,00,000, then the error is $50,000, right? This is the cost, but your model has predicted this one. So this is an error. There is an error, and that is we have given a term named mean absolute error. Okay, so this is just absolute error. Just you are just subtracting this value to your predicted value. Fine. Now this converts each error to a positive number. We then take the average of those absolute errors. For the first house, this is the error. You have taken the positive number. For the second error, it may be 30,000. For the third house, it may be 20,000. For the fourth house, there may be 10,000 error. So for every house, you have some amount of error. So now what you are doing, you are taking the positive values of each of the error and then you are adding them to make an average. Okay, you get my point. Let me repeat the whole thing again. You take the first house, you calculate the error. The actual value, the predicted value. The difference between these two is known as the error. So from the first house, you have got some error. From the second, you have got some error. From the third house, you have got some error. So you add the error of all the 10,000 houses and then you make an average of them. Okay. So you can understand how much percentage of error your model is making. This is how you can understand the quality of the model. Okay. So to calculate MAE, we first need a model. See, import pandas that you already know. This is the data set Melbourne housing prices. You are converting it into CSV file. Sorry, this is in CSV file. You are converting it into the data frame. Then you are deleting all those columns which have some missing values. After that, you have selected the target features, that is the price. Then you have selected the inputs, or you have chosen the features, right? So as you have got X, this is the input, Y, this is the output. Then you have imported the model, which is a decision tree regressor here. Perfect. Now you define the model and you fit the model. So here the training is done. X input, Y output. You have provided X, you have provided Y, you have provided the algorithm, which is decision tree regressor, Melbourne model. This is the object of this class, of this algorithm class. So you are calling the object, you are passing the fit function, you are passing the input, you are passing the output. So your model is true. Perfect. Now what you have to do? You have to evaluate the model. Okay, which is the main topic of this particular chapter. Now what you do? You import the mean absolute error, that is a function which is already written in the library scalar.matrix. Now predicted home prices equal to Melbourne model, which is the object of this class, which is fit dot predict. Predict function will predict from the input. So it will predict the value of x. Okay, x is the input. So now you are predicting this. Okay, so now you will if you just call this function mean absolute error, you pass the y value. Y is what? The output, and you take the predicted home prices. So this is the actual output, this is the predicted output. So you are taking the actual output, you are taking the predicted output, you are taking the function. So it will give you average error. Fine. This will do that thing which I have explained before. Like it will take the first house, second house, third house, and make an average of all the errors. Okay. So this is the actual value, actual output, and this is the predicted output. Okay, clear? Okay, now let's see, there is a problem. What is the problem? Problem with in-sample scores. The measure we just computed can be called an in-sample score. Why? Because we have taken a single sample of houses for both. For building the model, for evaluating the model. Same sample space. Build the model, evaluating the model. But that is a problematic. Why so? Let's imagine in a large real estate market, the door color is unrelated to home price. Very natural, but in the sample of your data, which you have used to build the model, all homes with green doors are very expensive. Okay, now the problem is that your model is subjected to find the pattern, and it will find a pattern that those houses having green doors are very high in prices. But that is not the reality. Okay, you get my point. Your model has found this pattern that having green door means it is an expensive house. That is in your data set. But the problem is that that is not true. It is not related at all. So since this pattern was derived from the training data, the model will appear accurate in the training data, because from the training data, your model has found this pattern, and when you are using that training data to predict the prices, it will appear accurate. But this is not. But if this pattern doesn't hold when the model sees new data, then the model will be very accurate. You get my point? Your model is trained on your training data, where it has been observed that every door, that the door having green colors are very high in prices. Those apartments are very high in prices. And your data is again validated using the training data set. So it will seem as accurate because the same pattern. But in reality, the door color is not related to the price. So there will be a problem. Okay. So since models' practical value come from making predictions on new data, we measure performance on data that was not used to build the model. So that is why we want to evaluate our model on some data where which are not used for training. Okay. The most straightforward way to do this is to exclude some data from the model building process. You have a data set of 100 rows. Now what do? You exclude some amount of data from the model building process. I mean, you will exclude 10 rows or 20 rows which will not be used for training. Okay. Then use them to test the model's accuracy. Your those data set like 10 data, 10 rows of data, 20 rows of data, model has not seen that data yet. Model is built. After that, you are using this data set to validate the model, to check the model's accuracy. This is what is known as, this data is known as validation data. Okay, coding it. The scikit-learn library has a function test split which will break up the data into two pieces. As I have said, you have 100 rows, so it will divide 80-20. So 80 rows will be used for training, 20 rows will be used for validating. Okay, this is the code. First, you have to import and then you have to write in this way: train X, validation X, train Y, validation Y. It simply means that your data set will be divided into two parts. Let's say that 80% is kept in train X, train Y. Train X means the training inputs, train Y, training outputs. Next 20% will be kept in val X and val Y. So 20 inputs are in validation X and 20 outputs is in validation Y. Then you are using the train test split. X is the input, Y is the output, and random state equal to 0 means it will give you same result every time. Perfect. So you have divided your data set into training part and testing part, or we can say validation part. Okay. Now what you are doing, you are defining the model, that is decision tree regression. After that, you are fitting the model. So Melbourne model dot fit train X, train Y. So you are taking the training X values, training Y values, and you are fitting the model. Okay. Once you are done, now you can validate the predictions. So Melbourne model dot predict val X. So now you are taking these values, these 20 rows, and you are predicting their output. Okay. So you have the actual output. Which one is the actual output? Validation Y is the actual output. What is the predicted output? Where you have stored val underscore predictions. This is the predicted output. Validation Y is the actual output. Now you are calling the mean absolute error function, which is taking the actual output, validation Y, and the predicted output, val underscore predictions. Clear? So now it will give you the mean absolute error. The same it will do for every houses. It will calculate the error and then it will average them. Wow, you mean absolute error for the in sample data was about $500 out of the sample is more than, let's see, this was the in sample value 434 and this is the out of sample value. Okay, so you can see that the model that is almost exactly right and the one that is unusable for most practical purposes. As a point of reference, you can see that earlier you may have thought, wow, this is a nice model, but now you can see, no, this is not. Okay, so there is a problem with the model. You cannot use it for practical purpose. Okay, so there are many ways to improve this model, and such as experimenting to find better features or different types of model. Anyway, now it's your turn. Okay, see, you have built a model. Now you will see how good your model is. First, you have to run the cell, import pandas from sklearn.tree, import the algorithm. This is the file path, the CSV file, and you have converted the CSV file into data frame. You have taken the prediction, that is Y. This is the input column, and now you are specifying the model. You are creating an object of the model. You are fitting the model. These are for printing something, and this is to set up. Perfect. So let's do this. First, you have to uh, you have you have to split the data. So first read all these things, then do one by one. So from import train test split. But let's first remove this, and you have to import this from sklearn dot model underscore selection. You can take help from here also. Let me show you. They have already started this. Where is this? This one. Sklearn dot model underscore selection. Import and test place. Split. Okay, fine. Now in the second line, give it the argument random state 1. Okay. So the check functions. Okay, no problem. So train X, val X, train Y, val Y. See here, I'll copy from here. This one. Try to do it by yourself first. If not, then take the help. Okay. So now if I run this, mm, indent problem. Okay. Now specify and fit the model. So Iowa model equal to, you have to, see here, you have to define and fit the model. So here Iowa model equals to the same algorithm. So I will take this one. You can use any algorithm here. There are so many algorithms. Create a decision tree regression model and fit it and set the random state equal to 1 again while creating the model. Okay, no problem. Now, random state, random state equals to 1. Okay, now fit the model. So, this is the object dot, you have to call fit function, and inside this, tell me what will be the answer here. Input and output. What is the input? What is the output? Chain underscore C. Exactly. This is the output. This is the input. Okay. So now we can run this. Correct. Now make predictions with validation data. Now you have to make predictions. So how to make the predictions? Model name dot which function? Predict. And inside this, prediction on what? You are predicting on valx. Let me show you. The same name, the valx. Okay. Now let me run this. Correct. Now you can print this and after that calculate the mean absolute error. This one I will not do. You can do. You can print anything. You can print off few validation rows, few actual prices. You print the X, you print the Y. You see all these things. Train X, train Y, validation X, validation Y. Okay, all these things you do print and you check what is there inside the data set. Now I will do this one. Calculate the mean absolute error in the validation data. So val underscore ma equals to call the function. Let me show you. I will copy from here. See exactly this one. Mean absolute error. So now you will pass what? You have to pass the actual output, which is the actual output, val y, and the predicted output. What is the predicted output? Val predictions. Okay. So you have to pass actual and predictions. Comment this. Okay. This is not a good model. So much error. So is that MA good? No. There is not a general rules for what values are good that applies across applications. We'll see how to use. Okay. So we have done this exercise. In our next class, we will study underfitting and overfitting. Okay. Till then, bye. Happy learning.